All right. How many people we got up north on deal? We got a good, at least 10?
Yeah.
Tonight, guys, I wanted to welcome Steve Sloan. He's with Sporlan Corporation. He's also has many years experience with Publix. Started as what? Bag boy or something?
No. It felt like a bag boy.
Worked his way all the way up to the top. He was the head of all the refrigeration and the new stores and the designs going on at Publix for many years, and he's half retired working for Sporlan now. So if you have any questions when he's done with his presentation, he's probably able to answer any of them that you have. All right, so let's get going. Oh, by the way, for you guys that have never been here, there are guys, maybe 15 or better online, and if you have questions, try not to shout it out. Raise your hand, and then we'll get your question, because I want them to hear what you have to say. If they have a question, they'll raise their hand. George will probably lift his hand, and they'll ask a question so you can hear what they have to say. All right? So let's get going. Steve, it's all yours.
Hello. How are y'all? Can you all see me on the camera? Because I'm not like a big camera person here. But let's see how big I've gotten over a couple years. I've been going for Publix from 5 years now. So this is 5 years of Sporlan. Another 15 years, and then I'm going to go do something else. I don't know what it is going to be. We're going to talk about the expansion valve story. We're going to talk a little bit about the operation, process, troubleshooting, installation, contaminant control on trying to keep and protect our expansion valves. Our plan is to do different classes as we go further along, getting into more electronics down the road on some of the other classes, but we have to develop those first. A lot of stuff you may have seen, may have heard some of this in the past, but some of it's a refresher for some guys and something new for others. Okay. There it is. All right. Expansion valve. The basic purpose of the expansion valve is to control the superheat. Some guys will say it's to sit there and measure and monitor the flow of refrigerant coming through the system. All expansion valves are going to do is control superheat. Basically, whatever you're full of common liquid on this side. Oh, that's that thing you told me not to do. There. Your temperature difference across your coil is going to be your superheat. So whatever the expansion valve is doing is all we're trying to do is control our superheat. Sorry about this. No superheat. This is typically what a system's going to look like. If you had glass pipe through your evaporator coil, you would see that you would have no superheat. You would have refrigerant liquid getting past your bulb, which is the next phase is start to get refrigerant back to a compressor on a single system, where you're getting it back into your suction side. So you're still having refrigerant getting back to your system. Normal superheat, you want to try to boil off your refrigerant about 3/4 of the way through your evaporator coil. And then high superheat, you're typically not utilizing all your evaporator coil. You're not maximizing, you're not getting full capacity of what the system's capable of. So what we're trying to do is we want to kind of keep that superheat at whatever the recommended superheat is that the manufacturer tells you to set the system at, so you can get the optimization of that coil. Parts of a typical expansion valve. This happens to be a conventional expansion valve. And when I say conventional expansion valve, I'm talking about an expansion valve that has 2 push rods. Anytime you see and you pull an element off, which will be your top section, which will be your diaphragm, your cap tube, and your bulb, when you remove that off of the expansion valve and it has 2 push rods, you can automatically remember and that's a conventional expansion valve. Now, if it were to have a single push rod when you pull that element off the top, that's a balanced port expansion valve. Okay, and we'll talk more about the differences in the two. Typically, if you look, this is actually our pin and port. We have our pin and port size, our seat. That's actually the Sporlan logo turned upside down. That's where they get the logo from, because originally we started with expansion valves. Sporlan is now around 81, 82 years old, so we've been around a long time. Then you've got your spring, and then you've got your adjusting stem. The one thing I really want to point out, because this is one of the things I see happening a lot of times in the field, on expansion valve replacements. Guys, I'll be at a counter day. I'll be doing a counter day. A guy will come up and look at one of my cutaways of an expansion valve. And I go, well, when I close the valve, or when I'm opening the valve, I'm turning it clockwise or counterclockwise. I want you to understand that you can turn this to the right, or you can turn it to the left. You're not closing that valve. these valves, the port is already closed because the spring pressure is pushing up on that pin and causing it to be in a closed position. So a guy is thinking if he's turning it and he's closing it, it would be true if you had a shaft that ran all the way up to the port and it was actually connected to the port, but it's not. You're not actually threading it like you do a bolt or a nut. So just understand that when a guy is going to sit there and make these adjustments, or you come across a tech that's doing that, you can explain to him you're not opening or closing the valve. You're just changing the spring tension to allow the valve to either work harder to open, or easier to open, or harder to close. Spring tension, just like your springs on your car. You get tighter springs, you get less movement on your system. And there's also another thing to think about is if you get out to a job site, and I know many of you get out to some of these stores and you're not quite sure where the superheat is, or you can't get the valve to work properly, we tell everybody, go ahead and turn it counterclockwise until it just kind of gets a little snug. And what that is, that's a stop pin. It'll actually snug down, don't turn it, wrench it real hard, and then count full turns all the way till it gets snug when you go clockwise, until it's like in the tighter spring compression, until it gets snug again. And count how many turns it is, and then divide it by 2. Just back it out exactly halfway, and that'll put you back at the factory setting with that superheat, where that valve came from the factory. A lot of guys don't know that, and they're out there. You don't know who's in there working. The contractor could have been a contractor who's never been on the job site, never worked for you. They've had some of the expansion valves get really out of whack after guys tend to play with them, because that's the first thing they want to do is set superheat, or they're out there trying to work on the superheat to make the system work properly. So just remember that. Those are some key things.
Are there charts that show how many? Can you preset a valve to a certain superheat without actually checking it with a gauge and a thermometer? There used to be charts that said that an F body could be 1.5 turns out, or every quarter turn was equal to a certain amount, or maybe it was degrees. I'm not sure, but everybody asked me about that. So you don't have to check superheat; they'd rather know what the chart says.
What the chart says, yeah. There used to be. We still. I can go back. You're asking if there's charts available to show where the superheat is per whatever type valve it is. What's the setting? If it's how many turns makes this much superheat. One thing to note is every full turn you make on a valve is about the equivalent of 4 degrees superheat. So neither one way or the other. So that's why we always ask you to count your turns. I'm not sure if they still have those charts or if they still publish them, because they really want guys to start really measuring the superheat. And that's one thing that will happen is every time if you call Sporlan's tech support, they're going to ask you, the first question they're going to ask you is, what's your superheat? Or if you're in the air conditioning business, superheat, subcool. They want you to know your numbers when you call them. And that's the only way they're going to help diagnose the system to that stage. That's just that's standard protocol for our tech support. And they're open, well, just whatever hours it is. They just closed.
Don't commit them.
Yeah. As I was saying, this is a pin and port. The stroke is all you have in the valve. A lot of people think that if you keep turning that spring adjustment, that you're going to get more capacity out of that expansion valve. You're not. That valve, whether you loosen that spring compression or you tighten it, you're not reducing. If it's a 3-ton valve, it's always going to be a 3-ton valve. It just may not open as fast because the spring tension may be too tight on that pin angle, so it has to work harder to get it to open. But you're not going to change a 3-ton valve to be a 2-ton valve, or you're not going to make a 5-ton a 7-ton just by loosening the spring tension. Okay, that's one thing. We only have so much stroke allowed in our valves. And I mean, we're talking, this looks big because it's exaggerated, but I mean, a 10 micron piece of particle would actually plug up a port in a valve. We talked about the conventional valves. Here's some of you I talked earlier. You talking about? Yeah, this is actually a conventional valve, 2 push rods. Just remember, this will be the Q valves. As you can build a valve, the Q valves have 2 push rods. It's got 1 opening force and 2 closing forces. Your opening force is always your bulb pressure. Your closing force is your evaporator pressure and your spring pressure. So what happens is when this valve is operating properly, if the bulb is calling to be open and these 2 things are balanced out in equilibrium, this valve will just continue to let refrigerant flow like it's supposed to, flow through the system. You You also got to make sure you got a good column of liquid going to that expansion valve, because of course it'll start flashing and causing the other issues that cause the valve not to work. But that's a 2-push rod system on an expansion valve, and I'll show you. I get questioned about how the evaporator pressure actually helps close the valve. We got some diagrams that actually moving animated slides that kind of show a little bit of it, how it actually works. And this is actually one of them. So let me kind of populate the slide a little bit. Okay, conventional rod, 2-push rods, conventional valve, and there's your typical valve and what it looks like inside. So it takes a few minutes to get this thing going. We're going to speed this thing up one day. So here's my liquid and my bulb, whatever it is. It's typically a gas that's going to match up with whatever refrigerant pressure, temperature correlation is going to be for the expansion valve. So if it's R22, it used to be a V charge, and we talk more about V charges later. But R22 valves are changed to an N charge. They're going to have an N because we're taking R22 out of them. And the same thing with 404 and 134A. You'll start seeing elements that will say SC/PC. That's the same element as what it used to be when it was just a SC or a PC separate. It'll be combination. You can use them for both refrigerants. So as my temperature starts to increase here, the gas that's inside the bulb, it moves up to the top of the diaphragm and pushes pressure down on these 2-push rods. Now my refrigerant flow's starting to come through my port on my expansion valve. And when we talked about, so now I've got my flow coming through here. We talked about the suction side being a closing force. Okay. The reason why the suction side becomes a closing force is once the refrigerant starts to get through this valve, it actually goes up through the ports and starts pushing against the bottom of the diaphragm. And that's why you start having, why it starts to act against closing on that. So you get the pressure that's coming out here and the pressure pushing up on the diaphragm is why the suction side happens to be a closing force of the valve. It's taking a little bit of time to change my slides.
Is that port on an internal measuring the outlet of the valve and on an external measuring the pressure on the outlet of the evaporator?
If it's an internal, it'll actually be doing exactly this. It'll come up through the valve. This happens to be a conventional valve with an internally balanced valve. So it only has an inlet and outlet. It doesn't have the third connection, the external equalized line. So this will be what an internal equalized line does. If you had an external equalized expansion valve which has the third port on it, the smaller 1/4-inch connection, that same pressure would actually start to come through and into the valve and push up the diaphragm versus coming up through the valve. Yes, sir?
What's the difference between you have some rods that are in there that are triangular in shape rather than round? Why?
That's just the specific type body valve that they made at the time. They had some, there were some older valves. There were some different ones. They used a triangular type valve.
Is that for better flow up through?
They do actually get a better flow because you know it's hard to get. You're still gonna have a round port with a triangular piece, so you're still gonna have a little bit more flow that you can get through there to help on the closing aspect of it. I haven't seen many of those valves for a while. I mean, I'm not sure which valve it is that we actually have in there with the triangular port.
All those Sporlans have. All the little blood ice machines have those.
Yeah, there's we have gauges. There's these little gauges that we have that you fold up, and it tells you they're hard to get because they used to be an old product we used to have, but you can unfold them, and as you're looking at, if you go up to a valve, and like I said, a guy took an element off, and for some reason the valve doesn't want it, every time the bulb tries to open, it overfeeds the valve. It could be because the pins are too long, is one of the things. So we have a chart that's actually, you can look at what type valve it is, and then match it up to you put this little chart on top of the valve, and it'll tell you if you got the right pins, and then you cut them off and file them or find the right pins most times. It actually allows you to cut them at one time, which that to me, I don't know, maybe that's pretty accurate to have to cut those things. That little stainless steel. You had your hand up.
But those valves are only for small self-contained units.
Yeah, I will actually get into, the small, if it's internal equalized, it's usually less than a 1-ton valve. It's at 1 ton and under you typically can do
Because the external would be more for
Yeah.
higher in tonnage.
higher in tonnage. Okay, so basically here we're talking about lowering the superheat from 10 degrees. We actually are running a 10-degree coil to 6 degrees. We're going to actually, yes, and you can't take this cap off. I know you guys know that. I've had guys that won't take this cap off because they think it's going to leak. If you take that cap off, it will leak. But if you take the bottom cap, you're fine. You can turn this one full turn to actually lower the superheat. As I said, it's about 4 degrees superheat when you make one full turn. You have little ratchets when you're doing your superheat. So how do you count turns with them?
The little circle.
You get the little circle ones, right? Yeah, but you can actually, I mean, I see some guys with surface wrenches just get on there and they start wrenching on it, and I don't know how they're counting full turns.
So just mark it with a marker, and then you
Count your quarters.
Counting quarters, yeah. We always try to do quarters.
And that one full turn, I want everybody to be sure, that 4 degrees is not on every valve.
Right.
On an F body, that one full turn could be 10 degrees. So they're different.
Mm-hmm. It is
Everybody
based on,
starts wrenching them on one full turn.
and you'll know real quick. See, that's the benefit though. Is once you know how many turns you've made, you can always go back. A lot of guys, if you just keep wrenching on it,
How long do you wait? Is it 15 minutes for a quarter turn to
we
That's
typically say 10 to 15 minutes is the wait time.
go that long?
Because you want the system to settle in. I mean, typically you shouldn't have to. I mean, when they come from the factory, you almost don't have to. You can let them settle in. If you got to make some adjustments, you make adjustments. Because the way they piece them together at the factory, it's like one person sits there all day long just assembling valves and making sure they're set exactly halfway. So I mean, we still want you, even though it's factory set. People tell us it's factory set. We tell them it's factory set. We still need you to check your superheat before you walk away. Actually reduce our temperature across our coil. We're dropping our superheat down to 6 degrees.
Which way did you go on that, Steve?
This
Clockwise or counterclockwise?
counterclockwise. That was counterclockwise.
We opened it up. We counterclockwise it up.
Yeah, you're actually you're reducing the spring tension. So that's all you're doing. And then of course on the you're gonna go counterclockwise to increase refrigerant on the evaporator. So anytime you go counterclockwise, you're making the balls have to work less. It's easier to work to open the valve versus against the spring pressure. This is once again, here we are, we're doing the same valve, we're going to raise it 14 degrees. This is, like I said, it is a rule of thumb, 4 degrees. Like, you know, if you're going to make a full turn, you want to go ahead and check it. So in order to raise it to 14 degrees superheat, we're going to make how many turns on this valve? Clockwise. 2 full turns. 2 full turns will get you from 6 degrees. Remember, we just made 1 full turn and brought us down 8. Yeah, so now we're going to go up 8, so it's 2 turns. And it just shows the flow. And then, of course, it'll change where it's going to boil off on the evaporator. So clockwise is going to increase your superheat. Counterclockwise is going to decrease your superheat. Yes, sir?
We got a question here.
You do?
Delaney, what's up?
Till you go to defrost.
So you go to
He said for a night, bro.
You know, actually, a dime does work.
It does work.
But just remember where you left your dime.
Yeah.
Because
You get it the next day.
you get it the next day, you'll be out 10 cents. But yeah, it does work. We don't encourage it. We actually hope you have a new element in your truck so you can go ahead and change it out because you don't want to have to make the call twice. Yeah, that is an urban legend. We don't recommend it though. Okay? It does work good though. Internal equalized line, we talked about rule of thumb. If it's less than a ton, go internal equalized line. If it's larger than a 1 ton system, there's your. Remember we talked about the bleed coming up to actually close the valve. It's doing the same function as what it does when it's internally equalized. So externally equalized line must be connected to the system. There's no way you can't cap it off or the valve won't work. And I think I get into a little slide of that. Yes, I got ahead. Yeah, because we've actually, this industry is really.
But if you're in a pinch and you've got a 1 ton or more, you can just cap that line off.
No.
No.
Never cap this line off. If you've got a valve and you're in a pinch, we need to connect that valve after the bulb.
No, if it's a 1 ton system or less, you can't.
No, you can't because this valve won't close. Remember, suction side closes it. Yeah, suction side closes it on a small 1 ton, a ton. That doesn't. It's an internal equalized line. It has to get feedback up through the top of that element. If you cap that off, you have no refrigerant, no way to get refrigerant to help that valve close. That spring can't close that valve by itself.
You can put an internal in a pinch. If
Yeah,
don't
you can
have
put an internal if you don't have external.
It'll work.
Yeah, but you got to connect
You
that.
can't do the other.
You got to connect it at all times.
And it has to be after
The bulb.
After the bulb. Okay.
Yep, and I get into some diagrams of where it's typically mounted and where's the practices.
So would it flood out if you cap that?
Yes. Yeah, because it has no way to close. The spring pressure won't compensate for what the bulb's reading. The bulb will constantly be putting pressure to keep that valve open. Yeah, you'll probably be there for other issues in a compressor failure. You'll have other issues. Yes, sir?
Could you use the power head for an air conditioner?
For commercial?
Yeah.
If you're in a pinch, you can. It'll just operate a little slower. It'll be at the pace of what the pressure temperature is in correlation to it. You can. It's just you need to try to stay with commercial. If it's commercial application, you want commercial. You can't use it for low temp application. It'll never work for a low temp.
No.
Now I know people probably say, "Well, I've done that before and it worked."
Well, I did it before.
That's why I said, I'm just teaching with the book. I'm the book guy. No. Yeah, sorry. We talked about external equalized line locations. Typically, if you put it, remember, it's a closing force of the bulb. It's a closing force of the valve, right? If you put it before the bulb, well, the bulb's if the bulb's not satisfied, it doesn't actually migrate back because the temperature is not in correlation to where it needs to be. Like if it senses the temperature's not right, that bulb's going to constantly try to be feeding. If you put the external equalized line before it. Now I know there's some air conditioning manufacturers that have engineered their system. They've already got the external equalized line connected before the bulb, and they ship the bulb loose on air conditioning air handlers and stuff. We don't recommend that, but they're the engineers. They're okay with if that's how they want it. They're fine. It's not gonna be an optimized system by having it because that valve's gonna be constantly fighting what the external equalized line's feeding it back at. So, yes, sir.
I personally have had valves that were not feeding, and when I pulled the power element to check the element to see if it lost its charge, a lot of oil came out, and when I put the element back on, the valve worked.
Mm-hmm.
Is that because the oil in the cavity that is causing the gas to not be an opening for it?
Yeah, if there's oil up in the cavity, it's probably something feeding back to the external equalized line. If you pulled the element off and you relieved that pressure, what you've done. Yeah, because there's no way, if you've got oil, that cavity so the pressure's pretty tight underneath there. So if you've got it's like having, you created a pocket. There's oil in there. It's a pocket that can't push down. Because typically the only thing should be through there is the liquid refrigerant or vapor at that point to push that element down, the diaphragm. I don't know. You could have had external equalized line on the bottom.
Typically, we have, in every case, the valves are on their side.
Right.
You can have a valve on its side, but I just never understood why the oil, if you had vapor pressure pushing on the oil in the cavity, you would think that it would still exert the same amount of pressure in the suction line on the oil. I don't know what It's a
Yeah.
common failure on valves. You take the element off to check it, oil comes out, put it back together, valve works. And they're always on their side, so.
Always on their side. Yeah, because I mean, we tell you you can put them in any rotation. You just have to have the bulb in a certain direction, and the external equalized line has to be mounted on the top of on the suction, always on the top. So I don't know why you would have had oil in there.
That's always after the oil always comes after it's been broken down for like a couple hours.
Well,
That's when I've always seen the oil, when the rack's down, and then you got frozen food cases that you go and you got valves that are oil in them, and then you oil lock them and they come out.
right, but that's the cavity that he's saying is an opening for, or closing, actually it's an opening for it, right?
Yeah, but it wouldn't be.
No, it's
The only
a closing force.
diaphragm is
It's
gonna-
pushing
yeah.
up on the diaphragm.
It's going to be a closing force. Yeah, it's closing force because diaphragm is
that
the only thing
oil,
that can push it.
If a fluid is in a cavity and you get a hydraulic lock, it could be slamming the valve shut.
Yeah, because you can't. It's just like you can't get that to compress out of there, get it out of there. I've also had some low temp applications where we've had the wax forming of wax with 404 and POE oil, and it'll actually do the same thing. You can take the element off, and you'll see like a gel. And the guy will think, what's a gel? Is your bulb leaking? The element's starting to leak out or something? And it's not. So actually, the wax forms on top of that where the element is and causes the valve to stick. So what they'll do is they'll change a valve. The next thing they're changing elements, and we actually get them to put a HH, which I'll talk more about contaminants. But they get an HH core, which is the green and white replaceable core, or a sealed filter dryer catch-all that's an HH, and it takes the wax out and helps that valve issue go away. Because wax is one of right now with POE and 404.
That's a new
wax,
stuff you got going.
yeah, wax is like, man, this is. Oh, there's even there's another thing that's going on, but the wax just in regular refrigerant. The air conditioning groups got tore up with another product, another contaminant, but I don't have to get into that one. Yeah, this is ideal location. Like I said, after the bulb. Balance port valve. Remember I was talking about the single push rod? Okay. This is where we get into the balance port valves are going to be used for variable loads when you get different varying type loads. You can have different characteristics going on in the store or into the application they're using it. Some of the big air conditioning manufacturers like to use balance port valves. They're actually on a balance port valve. Varying head pressure, so you have different head pressure issues. If you got variable speed compressors, you may go with a balance port valve. But what my little thing is like stuck behind that.
What's the matter?
It's not changing the next slide. Oh, I can touch the screen. Okay.
Want to go that one?
Yep, that's where I was headed. This is actually what the balance port valve is going to do. The difference is you have two opening forces, two closing forces. You have your bulb pressure, and you also have your inlet pressure, your opening force. You still have your suction pressure and your spring pressure. Don't look at the two push rods. That's been something that's been that way since I don't know what year, but they didn't change it to look right. The thing about this valve is when the compressor's pumping, I no longer have the inlet pressure sitting there pushing the valve to close it to open. So basically, I have to have inlet pressure to start the valve to open up. So if I was coming into defrost or I was on an off-cycle system, I could sit there and have, as soon as the compressor goes on, it'll get the valve moving and allow this valve to pull down the temperature faster. It's like having a turbocharger on your expansion valve. It brings the system back down faster under a low load or different varying load conditions. It's actually balance port valves it gets back into refrigeration a little bit quicker than the conventional valve, which has to depend on the bulb to sense temperature to open. I don't know how often you get into seeing some of the expansion valves that are out in the field. The nomenclature, this happens to be an OEM valve. I don't know, you could be working on some of the big rooftop units, and if you see an expansion valve, that is like, most OEMs use a BBI valve, a BBI-ZE or a BBI-VE or whatever it may be. But if you come across a valve with those nomenclature, I want to point this out is it is a balance port valve, but also this one happens to have a CBBI, which means I have a built-in check valve. So if you had to replace that valve, you don't want to go and just get a standard, OVE valve or something that doesn't have a built-in check valve. You want to make sure that you replace it with one that has a built-in check valve, or you're going to have some issues, come across some issues with that valve, because it'll flow, it'll fly, a biflow valve will flow both directions, but the purpose of the check valve is to stop the flow in one direction on these. So you want to make sure you replace with typically an aftermarket valve that has a check valve in it would be your RC valves that we have. An RCV or an RCZE have the built-in check valves. But that's just something I want you guys to be aware of, so you don't come out and see that nomenclature and then get kind of out there with an issue. This chart's a little bit old because we've had, of course, some different changes on this. All air conditioning applications, if you have these charts, all air conditioning applications are going to have the VGA or GA nomenclature for R22. 407A, it'll be an NGA. There's that NGA, which we're using the same charge for the 22. We've taken R22 out of the bulb. So now, as a manufacturer, as of January 1st, we can't produce anything that has R22 in it. So we had to change the gases so we don't have R22 in it because of the phase out. So now you'll start seeing NGAs out there. Like I said, you'll see the SCs, PCs. Just we're taking some of that gas out of there. Most commercial temp refrigeration applications are always going to have a C, a VC or a SC or a PC. So you can pretty much, when you go down and you look at your element, you see a PC or an SC or a VC, you can know that that should be a commercial temp application bulb. If you get to the job site and all of a sudden you see you're working on an air conditioner or a medium temp application and you see something with a VZ in it, a Z in it, you got a low temp application and trying to run a medium temp system or an air conditioning, and that will not work properly. And of course, anything with the X's are extreme low temp application. So if you just know, basically just remember that if it has a GA, it's air conditioning. If it has a C in it, it's going to be commercial temp. And the Z's are going to be your low temp application, and your X's are going to be your extreme low temp. And that's basically what that sums it up on that slide. I'm stuck on this thing. Yes, sir?
I just wanted to write it down.
Oh, okay.
Are you gonna go over pressure limiting valves or?
Yes, that's the next slide up on the elements.
How do they charge them at the factory to exact? I mean,
Man,
the tire elements.
the charging station is pretty cool because there's all these little wires and tubes, and we can't even as an employee, we're not even allowed to walk into that section because it has secret gas mixes. And they think that we do tours of our factory to contractors. You get to see it. They don't let you walk past that line, do they?
No.
It's and they have those little tips, and that's what they're doing. Is every one of those little tips that you see on the expansion of the element, that's their charging port. And a lot of guys don't know this. They're like, okay, we always tell you to mount it on at a 4 o'clock or a 8 o'clock position on an expansion valve on a tube, and you can actually mount it on a vertical line as long as that charging tip is pointing up. So basically, that little tip that you see we charge, if you make sure that it is pointing in the upward direction and then comes down to the valve, you won't have liquid, you won't have migration out of that bulb causing the valve to sit there and open and be stuck open. It has to force it out of that bulb. That's not really a published, it's kind of it's not a published thing, but it is in the last event that you have to do it on a riser, that's how you can mount it.
The little transmission tube.
What's that?
That little tube I said you got.
Yeah, to just make sure the tube is up and make sure the bulb's pointing down, and the tube and the exiting side of the tube goes to the
So
top.
it doesn't matter what position we put in the 2 o'clock.
No, not on a riser. It doesn't. Yes, sir.
Go ahead, Delaney.
Right. Yes.
On a vertical rise.
On a vertical rise. It doesn't matter on that. I'm going to show you the mounting. We got a little slide that shows where it should be mounted on a horizontal. That's the preferred method on a horizontal line. But if you don't have a horizontal line accessible, you want to make it where both tubes come out the top of the bulb and then go back down toward the valve. Okay.
What's the matter?
No. Did I answer that?
Is that good, Jay? Okay.
Pressure limiting valves. This is a lot of the smaller equipment. Some of the air conditioning manufacturers use these pressure limiting elements. And basically what they've done is we have a maximum operating pressure that this element will open at. So what it's done is, you can either put a CRO, a crankcase pressure regulator on a valve, or they can put hard start kits on the systems. But they're able to do the same thing with an expansion valve element that has a limiting pressure element on it. So if it has like a CP100 or a VCP100, it just means my factory air test, I'm going to be at 100 psi, that I'm not going to let that bulb open anymore, whatever temperature correlation is to pressure of 100 psi. So what it's doing is it's allowing to protect what's coming back to the compressor under pressure. So when it cycles off, that valve will never let anything over 100 psi get back to the compressor. So typically, if you happen to see these pressure elements, and you start seeing this nomenclature, even if it has just a standard, SCP, that means it has a pressure limiting of 75 psi going back to it. It's limited to how much pressure it's going to let pass it, and before it starts to reduce the pressure and allow the valve to not open. Because we're doing it to protect the compressor. It acts just like a crankcase pressure regulating valve, but it's the least expensive way to do this. I wouldn't say do it on every system, but a lot of the smaller equipment manufacturers like to use these because they don't have to put hard start kits. They don't have to put all the other extra valves that you guys deal with in the supermarkets. I would not tell you, well, I'll tell you, if you have one of these, when you're changing and it failed, make sure you put the same type element back on. Do not go and use whatever you have in the truck that may not have it, because if you put one on there that'll open up at 200 psi, you could scramble your compressor and have other issues. And especially a startup, you could overload it trying to start up. That's a critical item. It's an expensive means of doing this. Some of these other features we do. This is kind of nomenclature of the valve, so you guys can kind of see. I mean, EBSVE, we kind of break it down. If you're reading across a valve, we have lots of different safety mechanisms for us to, if you're trying to identify a valve, like the Q valves have a little tag. It'll tell you it has a 2, you put a little tag on it, or it'll have a 6. It'll tell you the capacity. Just by looking at your chart, you know what that little tag means. It tells you what refrigerant the element's going to have. Well, same thing with our valves. These are built, this is a built valve. It's our extended in is the first E, always tells you it's an extended in valve. It's an EBS valve. It's a balanced port, because if it has a B in it, it's typically a balanced port valve. Just like the BQ valves are balanced port valves. Like the Q valves aren't, but the BQs are. Those are build valves. And actually, with those BQ valves, you can build 410A, or you can't with a Q valve. Don't know if you have to deal with 410 building them, but there's your EBS. The next nomenclature letter is going to be your V, which tells you it's an R22 valve. Our numbers for refrigerant match up to anybody else's. The typical refrigerant has its own letter next to it. S is 404, J is 134A. So if you see the valve has a J on it, you know that valve was designed specifically to be a 134A valve. This one happens to be an R22, and the last E tells you it's externally equalized. So if all you can see on that valve are these numbers, or these letters, and then 11, you know it's going to be an 11-ton valve. You can actually go and replace it if you have to, or you can clean these valves up and build them. There's typically nothing you really have to replace a valve. It's a expansion valve. The only thing you typically have to replace is an element. And then of course, then we get into our charge, the GAs for air conditioning, inlet, outlet, and then the rest of the nomenclature. A lot of times if you look at the box, we now put it in fractions. We used to just put it in, like a 5/8 would be 5 by 7. It's just a mathematical formula. 5 divided by 8 gives you the connection size. Or excuse me, 8, yeah, that's what it is. Common problems with expansion valves. You're going to have debris in your water, non-condensables, flash gas in the liquid line. Improper bulb locations or mounting. We'll talk a little bit about the bulb location and mounting. Then we also talk about, let's see, proper size of bulb. I think there's a note I wanted to tell you about on one of those. I'll think of it probably later on one of the other troubleshooting slides. Anything we tell you, anything inside the system that's not oil or refrigerant is a contaminant. I mean, there's a lot of additives out there that guys use. Sporlan stand is always this. So people ask us all the time, well, what do you think about whatever this other product is? We just refer back to our standard answer that we've had for years. It's not oil or refrigerant, it doesn't belong in there. Contaminants, we talked about, there's acids. A lot of things about, I don't know if you guys have done refrigerant, POE, but I don't know. POE was a refrigerant that is, POE oil was actually an acid. Then they removed the moisture out of it to become an oil. So if you get moisture back into it, as you know, if you're working with POE in a system and how you open it up as a hydroscopic oil, it'll actually pull moisture back into it. Well, once it gets the moisture back in, it's starting to create itself back into an acid again. That's why it's critical to make sure you know, when we talk about how to control acid and control moisture, some of these POE oils, you have to keep the moisture out of these systems, or else you're going to put it back into its original state. Now, I'm not a chemist, but that's just typically one of the known things about POE oil. Moisture, the wax we talked about, there's something we don't understand what happens with the wax, what creates the wax, other than higher, like we know it's high discharge temperature. Sometimes we'll take the POE with the whatever oil or refrigerant you're using. Yes, sir?
Delaney, go ahead.
If it had mineral oil already in it, are you?
Drain the oil.
Oils. Probably a mineral oil system, and he took a new compressor with polyester charge and he put it in and started it.
You know what?
Sporlan
I have to
doesn't
leave that one for
stand on
Copeland.
Yep.
That's
a Copeland question.
I hate to tell you that. I mean, I think you're going to agree on an acid. There's going to be an acid or a contaminant in the system, but unfortunately, I haven't answered that one.
Our answer is that you're partially starting a retrofit.
Well, I believe POE actually is like a scrubbing agent. It'll get in there, start collecting.
It'll collect all the stuff.
Yeah.
It'll knock the dark off.
It'll knock the dark off. Yeah. I'm sorry, I couldn't give you another answer to that, but yeah, just make sure you don't do that.
It'll be just like when you put alkabenzene in mineral oil.
It's the same answer I gave to Laney.
Of course, a lot of the installs you're doing brazing, so you're going to get oxide scale, you're going to get metallic particles. You can plug cap tubes. I know we don't use too many cap tubes. I don't think we do.
We always burn with nitrogen, so we don't have those problems.
Yes, you don't have any of these issues because you use flowing nitrogen, and a lot of it, right?
A lot of it.
Sludge and varnish. A lot of the varnish and sludge will come from when you have a burnout. You may have some residue left over after a burnout. You've got to get that cleaned up. And we're going to tell you, using the right kind of contaminant control is going to help you get that stuff cleaned up. I mean, you may have to do, an oil change, or you're definitely have to do an oil change, but you may have to do, just keep changing some filter dryers or cores. This is actually what a contaminant looks like. I know you really can't see it, but it kind of this is a piston that actually has some wax buildup on it, and it actually creates like a little gum residue inside the piston. And once it gets on the piston, of course, it's going to cause that valve to stick. And it's like I said, the biggest issue with this is usually the lower temp applications, and 404 POE. For some reason, POE just doesn't like low temp application with 404. Desiccant blends. There are some desiccant cores, replaceable cores that you can get that are 100% desiccant for water. But for years we've been doing a blend. We like to be able to capture. You want to capture as much moisture as you can. We use a blend of the molecular sieve, which is your water, and the activated alumina takes care of your acid. We want to be able. We know you're not going to always capture every bit of moisture in the system, but any moisture that's in there, if it's going to cause an acid, I want to be able to capture that acid too. So that's why it's really good to make sure you have a core that's going to capture both products in there. It's a molded core, so it has to pull it through the core. I mean, it doesn't go through the center of it. We actually cause the way our design is, it actually wraps through around the coil and down out the center to the location it's going. As I said, same thing with the sealed catch-all. It's going to come in. There's no screen in the entrance of these, on the inlet of these. So what's happening is you've got your liquid refrigerants coming through here. It's going around the outside the core because we force it to go around the core. Then it slides through it comes through the core, which is pulling the moisture and the acid out of it, and then it goes out the center. It goes out a screen, filter, and then the center. So now you've got the cleanest you're going to get out of a filter dryer. And the one thing that's good about the way the core is designed is you've got all this empty space. So if you've got any kind of particle that's coming through, it's going to capture here, but it's not going to go through the core. And you're not just capturing it at the inlet, you're capturing it on the whole shell. So you've got some volume where you can capture a little bit more debris than you can if it was just capturing at the inlet. Are you changing these on me?
No.
Okay. I talked about the HH core. It has the combination of the molecular sieve, the activated alumina for water and acid, and then we also have carbon we add to. The carbon is what removes your wax in the system. That's why those HHs, after you do a burnout, or if you have wax build up from a POE, the HH has the carbon, and that's what gets rid of the wax. Highly recommend. You can mismatch cores. You can put an RC4864 blue and white core with a green core. You can mix match them if you have to. It's not going to hurt anything because they're the same size core, and now you're actually able to capture a little bit more of your, you'll pick up some little bit of acid and wax if you have to. We do have different cores. The RCW48, the gold core, is for POE, and that works totally different. It still pulls moisture and acid out of the system, but it's designed to have it pulled through the core versus these will pull it immediately. As soon as the moisture hits it, it collects it, whereas the RCW48 draws it through really tight and forces it into tight composite type material to squeeze it out basically. Two different systems. Yes, sir?
So if you got moisture in a rack, you'd recommend the HH for the golds?
If you got moisture, I would do the HH for that. I do the HH because you have acid or wax buildup.
Right.
I would use the RC
Gold?
No, the blue and the gold. You can do the blue and the gold. If you have a lot of moisture, I would. That's a high moisture filter dryer. I would use it. A high moisture. I'd mix them.
And you can't use the blue on polyester?
Yeah, you can.
You can't use the blue on 404?
Yes.
You said gold is for 404.
Gold's for POE. It's designed specifically for POE. But we have use of the blue, the RC4864, the blue can cores are used with POE all the time. Yeah, it has a really high moisture acid capacity. I mean, it's pretty cool because you can actually take it and open the can and pour water on it, and the can will get super hot, and the moisture will just be collected in the core. It's it picks it up immediately versus the other one has to pull it through it. Yeah, we have them using them in both.
Just wanted to make sure we're doing it right.
Like I said, the contaminant, we get the wax removal and oil cleanup. Sorry. Making sure that things jumping around. I keep seeing two different slides over here that I'm moving to and the one I'm at. So it's okay. That's the one I'm at. I got it. Variation, different types of shells we have, sealed shells. If you ever look at the back of your cores, if you got a really bad burnout, if you look, we have this filter dryer. It's called a secondary filter dryer. I highly recommend if you're going to have to do a cleanup, you can get them in single core and you can get them in double core. It's an FS. It's an FS 480, and then it has different number, and then the bigger it is, it becomes a 2-core. It's actually like putting a sock down the middle. It fits right over the mesh screen. You slide it over, then you put the cores on it. It actually gets down to 20 microns, so it picks up stuff that the cores won't pick up because they're a little bit. The total core is a higher micron pickup. It's like bigger particles will get through, whereas the sock actually you can throw it out on the core change. So it's a secondary core. You can pick them up. It helps on those cleanups. It helps speed it up a little bit. We talked about bulb location, horizontal runs. How are we looking on time?
The half hour, 35 minutes.
Okay. I can get going pretty quick. Horizontal runs. Try to mount them on, like we've got it drawn here with the tip. It doesn't really matter if the tip is up or down on this. Just we want it flowing past the end of the bulb, just like it's shown here. Don't mount it on a joint. You're not getting a full thermal conductivity around it. Don't duct tape it on there. Use the straps. This was this is kind of location typically on some of the line sets. The 4 o'clock and the 8 o'clock is where you're typically going to mount it. If you mount it on the bottom, you're going to probably pick up a little bit more oil and you're going to give a false reading to your bulb. We're trying to pick up, we don't want to pick up the oil, we want to pick up a little bit more of the, a little bit higher up so we can capture the valve will open like it's supposed to.
But isn't that depending on the size of the line set?
Yes. So you could be at 3 o'clock, 9 o'clock, or as long as you're not on the bottom, or if you're not on the top, because you're on the top, you're not going to ever sense any kind of, you're not going to sense what you need to
So
open.
the smaller the pipe is, the higher you go.
Yeah, you can rotate it around. I won't say this, I'll say this. I was showing this slide, and a contractor has been in business doing a lot of stuff. He asked me, his technician goes, well, what do I do if it's 2 o'clock in the afternoon? I said, you mount the bulb. He thought this is the times when you mount bulbs. So, it's, and then when it was,
Where was this?
sometimes you get, no, it's down in Miami.
Oh, no.
You should have sent them home at the same time.
I'd have to, man. All the guys basically almost.
In Cuba, they run in different times.
You know, actually, they do. And in Cuba, the United States, they don't have expansion valves over there. And sometimes an old guy is telling me how he sets superheat. I said, how do you set it? He said, we don't need expansion valves. He takes a cap, he's got a line, it's the inlet. It could be a liquid line. I think it's a 3/8. And he says, basically, we crimp it just enough until the superheat's where it's supposed to be. And if you crimp it too much, then you got to cut it out and replace it. But that's what they do. He said, my dad told me that in Cuba. I'm like, really? But he's over here working, buying valves. He's using expansion valves like you're supposed to. He said, because that's always not scientific, but it works. I'm thinking, my gosh. It was pretty interesting.
Gotta come up with something.
I get to hear a lot of stuff.
Jamaica's just bad, bro.
Don't trap the bulb. Obviously, if you've got a trap, you don't want your bulb in the trap because you're probably going to have oil buildup. We talked about putting it on the vertical lines. Manifolds are not a good location for it because you're not actually picking up all your you're not sensing off of everything on it. We're going to act like that's the tip. So if you had to do this, your tip's going to be up, your line's going to be up, and you're come back down your expansion valve. Any direction of a bulb, you can mount it in any direction, any rotation. We're almost done. I just saw a preview.
Okay.
Sorry. I like the slide over here. Here's some different situations.
This is about 4, so it's all right.
Was that?
We've skipped about 4 slides.
Have I skipped them?
No, it's all right. You're on track.
Okay. Feed's not enough. This is typically what your line set's going to look like if it's not feeding properly. If it's feeding too much, you're going to have a full column liquid leaving your expansion valve. If it's hunting, if you got valves that are hunting, you're going to start seeing this kind of trend pattern going across outside your valve. And of course, if you're doing your flood back or startup, you're going to start seeing this. So when we look at it's not feeding enough, One of the things we look at is moisture and dirt in the pin and port. We try to see if there's some moisture. We look at our, if you're not feeding enough, you can have an undersized expansion valve. You get the wrong element on there. There's lots of different areas to look at when you're doing diagnostics of the system's not feeding enough, or if it has a high superheat and a low suction pressure. We look at refrigerant charge, because I know that's an issue. You'll have issues not having the proper amount of refrigerant in the system, as well as you can have a blockage in the system if you've got an issue. You want to make sure you have a full column of liquid going to the expansion valve, correctly sized expansion valve, and the right elements would be the first thing I would be looking at on this issue for not feeding enough. Feeding too much, basically, I got an oversized expansion valve. This could be any of those, you got the Q valves. If they put the wrong size cartridge in, you get, or the technician that was before you guys even came to the location, they could have went and got a 5-ton valve, and they only needed a 4-ton load, so that would cause you to have this issue feeding too much. Bulb location, we always ask where the bulb's mounted, like if you're having an issue where it's feeding too much. It could be in a hot area in the system. It could be, if the bulb's not hooked up, you could possibly be having, if they ship them loose and the technician didn't mount the bulb like it was supposed to be, it could be mounted in the wrong place. Most times it's shipped loose on air conditioning applications. That's what they typically do when they package this stuff. Once again, wrong thermostatic charge. You want to make sure you have the right charge. That's why I said, look at those nomenclature. You can call any of us. How do you know that, man?
Delaney, go ahead.
It would open it. You probably never get it to. It would open the valve.
Don't do side work.
Yeah, you don't want to do that because if the bulb's going to cause the valve, if the valve's going to stay open with the bulb off there, you're going to obviously have refrigerant liquid getting back to your compressor.
NYC, man.
NYC.
It's uncontrolled.
Call the AC guy.
Call the AC guy.
All right.
Do you have that situation going on right now?
Oh shit.
At the house.
With the dying too.
No.
Oh, he did it. Oh, I didn't know you can hear you all the way back there. No, don't do that. No, change the element. I would definitely get that thing changed and mount it. Get it mounted properly.
Hire a real technician.
All right, Jamie, you got a question? No.
So they had an expansion valve. They had an expansion valve bulb mounted to the liquid line. Somebody just brought this up to me. I think it was one of our guys who lives with Walmart knows what their strategy is, why they do it. And I wrote a paper, so I'm gonna have to see if I'm gonna read the paper, and if it is, I'll send it to you guys to explain. I've never seen that before. I mean, typically, you see, I've only known to run them off of discharge air. I mean, and unique things. And I actually, there's a paper on what their strategy is, and I forgot what it was off the top of my head.
Thing,
And I would run it open. Yeah.
yeah, they love to run full. What if
So
you
they're
got-
using the CDS valve one. Yeah. So
They're using CDS valves, but they're defeating the purpose of the
the
coil.
expansion valve, they're just run the valve open with the CDS valve, back it up, hold it
That's
back.
why they do better with sorters than they would be with.
I've never,
But you won't get super.
yeah, I've never seen that before.
I don't care about the heat.
If he's running off a discharge, he's gonna be able to run that valve. So the case is obviously, he's getting the temperature he needs back. Yeah.
Is the CDS valve and the expansion valve in series? And if they are, what's first and what's last?
Well, the expansion valve operates, everything works off the expansion valve first, and the CDS valve is just your constant pressure, just holding it back. I mean, the expansion valve is still dependent on that system still depends on that expansion valve. Is how those are set up. I always wondered why you couldn't do without the expansion valve and just use the evaporator pressure regulator and hold it back. But then you're not getting your pressure drop across your coil you're gonna need to get. That's like the expansion valve's up on the front.
I don't know, it would be like a flooded coil.
It would be a flooded coil. Yeah.
The whole purpose of the expansion valve is to maintain it.
You're gonna have, you can't, you have a flooded coil and that, you wouldn't have any way to boil it off, the refrigerant if you didn't
It
have
would be
that.
like Mr. Delaney's bulb in the middle of air on his air conditioner. It would be an uncontrolled valve wide open.
Yeah.
So a 3-ton valve is a 3-ton valve.
It's 3-ton valve.
It's not a heater. That's odd.
Of course, flood back, oversized valve.
Doug, go ahead. Yes, sir. Hello.
Yeah.
No.
No, no.
Shake your head. Yeah. It just depends on the design of what they're trying to. A pulse valve is it's like a solenoid valve. It's either open or it's closed. I mean, you could.
Yeah, but they don't want that.
No. Yeah, you want the valve to you're still controlling superheat with the expansion valve. That's why I think we did the CDS conversions. It was all regular valves stayed the same. We just put the evaporator pressure regulator to hold the
Yeah,
suction
the
temperature.
TXVs don't stay the same.
Nothing changes on that. You still want to use the TXV. I don't think you could do it without it. I honestly don't think you could do it without an expansion valve. You could use a pulse valve, same thing. Have a controller run that.
Our head on there and you put the liquid line in cold weather conditions where you're dropping your subcooling down, then that valve would actually throttle. If you're measuring your liquid line. Now, if you get your liquid line down to 60 degrees or 50 or whatever in cold ambient, then that valve would actually throttle.
Yeah, I'm gonna have to
I don't know.
look at what Walmart did because I just got the information the other day. Yeah, that sounds like a complicated system. What they're trying to do. I'm surprised they didn't split it up into two systems. Two circuits.
Yeah.
It'd be a lot easier to do it in two circuits than trying to do four or five circuits like that.
Walmart lives by their own law.
I'll tell you what. I'll see if I can get some information on what some of their strategy is. Cause I got a guy who's out in Kansas City and he calls on the Walmart headquarters, and I can see if I can get that, and I'll just send you guys an email on some of that what their thinking is or the reasons why they do some of the stuff.
For even if it's cost efficient.
Well, they're pretty. They try to be innovative with a lot of stuff. I mean, they're doing a lot. I mean, they were doing. I think from what I heard, they were doing they were doing glycol, and I think they're moving back to DX systems with CDS valves, just because it's hard to prove that benefit for glycol in the temperature. The cost for glycol systems is just so much more expensive than a DX system. So you got more refrigerant, and you with CDS valves now you can basically. We're gonna do a CDS class in electronics troubleshooting. I'll be putting that together for you guys, but yeah, you can run a DX system with a CDS technology just like you can the same temperatures as you can with a glycol system. You just got a little bit more refrigerant in there. So I just remember that external equalized line has to be mounted. That's one of the things I want everybody to remember that. And the valve is purpose is just to control the superheat. So you want to be able to control the superheat across your evaporator coil. So this is, I know it's probably not as technical as some people are probably ready for, and it's probably, it's a refresher. Sometimes guys forget some of the basics. So we're going to start trying to do some of the other things to help you on some other more advanced classes. And that's my last one.
Questions? I had one.
Yes, sir.
What's your question, Pete?
One of my students, we were going through filter dryers, asked me, how does a reversible filter dryer keep moisture in when it's reversed? And I didn't have an answer.
Well, it's a desiccant. It's that desiccant stuff. So when it's in reverse mode, it still captures just like it was if it was in the standard flow. Moisture collects and it absorbs it by that desiccant product that's inside of the desiccant molecular sieve.
Right. So any of the particles on the outside of that core,
They stay inside.
they don't go back out and clog up?
Nope, because you actually have these. If you were to cut one open, you're gonna have a plate. You're gonna have a check valve and plate on both sides with pads. So what will happen is when it goes in the reverse mode, it actually spins it to a different rotation of the core and goes through. So it never washes whatever's inside that core out. So.
And when replacing filter dryers, is it customary, or should you heat the dryer with a torch?
Well,
Get it warm so you don't get it all frosty or something when it pumps down?
No. I mean, we just tell you when you're pumping it down, just go ahead and take it out. You're saying so it's warmer, so it's getting frosty, huh?
Well,
We don't use a
liquid
torch.
lines get frosty on pump down, but you want to heat the filter dryer prior to taking it out.
No. Yeah, and what we do is we tell most time when you're taking the filter dryer out, we recommend you use pipe cutters and just cut it out, so you don't have any issues if there's anything still stuck in there, or you don't have any issue with a torch catching somebody. We recommend you cut them out. Same thing with expansion valves. Guys like to unsweat them. Yeah, just go ahead. We just say cut them out, especially if you're going to send it back for warranty. For us, if we want to go send it back and see what may have been the cause.
Yeah, but we're limited on pipe. So
I know.
can't be cut out.
Hey, Delane, do you have anything, or are you good?
I know you guys have been sweating them out years, so I'm not going to tell you not to do it. Let me tell you.
Who's your compressor? My new condenser. Come on, man.
Hire a real technician.
Where are you located?
South Carolina.
Okay.
South Carolina.
South Carolina. And they're
What kind of unit you got? I'm on the beach.
What kind of unit do you have?
Walmart?
Arco here.
But that's a new condenser, so it'll work. It all got to do
Well,
with
you know,
airflow.
they all come with
All
bulbs.
got to do with airflow. It all got to do with airflow. What kind of where is it located? Airflow.
Yeah, because if he's having to warm it up to get it
Because
going.
what's happening, leave it open because it's probably closing. and not feeding the coil
It
because
gets into cool air environment. Did you wrap it or was it insulated?
okay, right.